Hello, this is the 7th video of the 3rd complex number series of OCR Pure Core AS Further Mathematics, and it considers the regions defined in the complex plane. We have previously looked at loci, sets of points obeying given rules. Regions are usually shown as shaded, including the area of points within. An example is given in this slide, where we are going to shade the set of points for which modulus of z minus 3 minus 4i is less than or equal to root 5. Previous sections we looked at the modulus of z minus 3 minus 4i equal to a constant number, for example root 5, and that led to a circle. We are still going to get a circle, but we will be shading all of that region rather than just looking at the set of points around the circumference. Just as we did with the loci, we will rewrite the modulus as z minus 3 plus 4i, which gives us the z1 that we're after at the point 3, 4. This then is the centre of the circle, and the radius of the circle will be root 5. Points on the circumference of a circle are included because it was less than or equal to. For a similar example where we only have less than root 5, then the circumference of the circle would not be included. In this case, then the circumference would be shown as a dotted line. For the situation in which we're looking at the modulus of z minus z1, in this case 3 plus 4i, greater than or equal to r, in this case root 5, then we will be looking at to shade outside the circle. This is shown on this Argand diagram. In this case, because it's greater than or equal to, then the circumference is included. We may also have to find regions that are described by the use of an argument. In the previous section on loci, we got used to finding arg of z minus z1 as equal to a particular angle theta. You may remember that this loci was a half line starting at z1 with angle theta. In this example here, z1 equals 2 plus 0i, and that would be our start point. The angle will be between 0 and pi by 4. So this is the region that would be shaded. You can see that it lies between y being less than or equal to x minus 2, shown by the line drawn up from the z1 equals 2. The line x is greater than or equal to 2, and also the line y greater than 0. We know that we have a dotted line along the y equals 0 axis because the argument was greater than 0 rather than being greater than or equal to 0. Whereas this line here will be included in the region because it was less than or equal to pi by 4. In summary of this session and the previous session, we have considered loci given by circles of the form the modulus of z minus z1 equals r, half lines of the form argument of z minus z1 equals theta, and also lines of a form where modulus of z minus z1 equals the modulus of z minus z2, if you remember that as the perpendicular bisector between two fixed points. Regions have been defined by the above loci, but in conjunction with inequalities. This was the last video in the Complex Numbers 3 series.